Now, let's solve a question from the IB Questionbank. For a study, a researcher collected 200 leaves from oak trees. After measuring the lengths of the leaves in centimeters, she produced the following cumulative frequency curve, and we have this cumulative frequency curve. If you can realize, it has an S shape. For part A of the curve, we need to write down the median length of these leaves. Now, for part A, my median position is simply equal to 50% because it's half times the total of my data, which is 200. 50% times 200, it gives me 100. So I go to my cumulative frequency curve. Here is the 100. I cross a line and I go down to find the value of the mean. So I find it's 9. So the value of the median, is 9. So the median value is equal to 9. This is for part A. Part B, write down the number of leaves with a length less than or equal to 8 centimeters. So now for part B, I have to go to the 8 centimeters. Let me choose another color. The blue, I hope. Okay. And I go to the left so I can find out the number. I will find that from 0 to 40 leaves, they have a length less than 8 centimeters. So for part B, I have 40 leaves. Let's check now part C. The researcher finds that 10% of the leaves have a length greater than K. 10% of the leaves have a length greater than K. Then I have to find, in my case, for part C, the top 10%. I need the top 10% because K, greater than K, there is 10%, so I need to find the top 10%. So the 10% of the total, which is 200, this will give me 10% times 200, 20. So in my curve, I will look at the upper 20 values here. The question wants to find the value of K for which is the length of the leaf is greater than. So from 200 to 180, I have 20 leaves. This is the upper 10%. I go from the 180, I draw a horizontal line, and I simply go down . So I'll be having K to be equal, it's exactly in the middle in here, which is this 10.5. So the leaves which have a length greater than K to be 10%, I'll be having the value of K to be K is equal to 10.5. This is the value of K. After that, I found the value of K to be equal to 10.5. Before measuring, the researcher estimated K to be approximately 9.5. We need to find the percentage error in her estimate. Simply for CII, the percentage error is equal to the absolute value for the value approximated minus the value exact over the exact value, all of it times 100%. So this is equal to the value approximate, which is 9.5, minus 10.5 over the 10.5. I take the absolute value, which means I take only the positive outcome of it, times 100%. I go to my graphical display calculator now. I have fraction 9.5 minus 10.5 over 10.5, all of it times 100. I'll be having on my calculator a negative value, but simply I will neglect the negative because I have absolute value. It will give me 9.52%. So the percentage error is simply equal 9.52%. And by this, we could solve this cumulative frequency problem by first, we wrote down the median by finding the position, which is the 50%, and then we wrote down the number of leaves, which are less than 8. After that, we found the top 10% and we found the value of k for it, and then we calculated the percentage error for that approximated value.